Hey everyone, welcome back. Last week I walked through Azure API management as an AI gateway, and we saw why it is important to put it in front of your OpenAI deployments. Today we will expand that. Today we will take that piece and we will see how that fits in a real production architecture. So let's get into it. Let's start with this diagram because here on the left we have the demo. It's something that you have seen. We saw it in the last video. It's a simple application calling an Azure OpenAI. We saw that this is not a good practice if you want AI governance. Also, if you have multiple applications hitting the same Azure OpenAI model, this is not good. But in the right side, we have a real production architecture where we have clients, we have API management, OpenAI, AI search, and so on. So today's video will do two things. I walk through every layer of this architecture and I will explain the design decisions behind them. And also I will open the code editor and actually show you the parts that make this work. Here is the full stack of our architecture. Let me name it from top to bottom. At the beginning, we have our frontend. This is what the users will be hitting to. Then we have Azure API Management acting as a control plane for our workloads. We have Azure OpenAI using the new Microsoft Foundry. This is where our model deployments will live. We have Azure AI Search handling the retrieval. This is going to be our RAG layer. And in this part, at the end, we have the internal enterprise APIs, handling your internal data sources or business services that you have. And cross-cutting all this, we have two things: managed identity as the authentication layer and APIM size using Azure Monitor for the observability. Let's talk a bit about each layer, starting with the frontend. So here is what the user are hitting. It can be an app service hosting a React frontend, an Azure container application, or a bot framework, whatever you are using, Copilot Studio, and so on. The real constraint here for this production architecture is that the frontend should never call directly the Azure OpenAI model deployment. Why? Because the moment that you let your frontend call OpenAI directly, you bypassed every governance control that you have. You can enforce token limits. You can have centralized logs. You can rotate the OpenAI model credentials without having to update the frontend. The frontend's job is very simple. It should only call Azure API Management. So there's only one outbound call to Azure API Management. Azure API Management sits between your frontend and everything behind it. So it's an AI gateway at the end of the day. And we will be doing four things primarily. The first one is token rate limit using the LLM token limit policy. And the reason for this one is because Azure OpenAI by default enforces limits at the deployment level. So if you have multiple applications or consumers using the same deployment, one can saturate the entire quota. With this policy, you can enforce tokens per subscription. The second thing that we will be doing, and you should be careful with this one because it can be expensive, is PTU spillover. This basically means that when you provision Azure OpenAI, it should have a provision throughput deployment. So let's say that I have 100k TPMs. If I run out of 100k, what I will get is 4 to 9 errors. So this will avoid that. And what APIM is going to do is that once we hit the capacity, it will spill over to pay as you go so that we avoid any 249 errors. But be careful with this one. The next part is semantic caching. APIM integrates with Azure Managed Redis to store embeddings of previous prompts. So when a new request comes in, APIM check if it is semantically similar to what it is stored already. This will help to reduce the tokens consumption because it won't have to call Azure OpenAI. And we will use two policies for this one, which is the cache lookup and the cache store to store in the embeddings if it is a new prompt. And finally, Azure API Management will authenticate to Azure OpenAI using its system assigned identity. So you will only need to assign APIM, the cognitive services user, on this resource. Behind APIM, you have your OpenAI models inside Microsoft Foundry. So in production, you will usually have multiple deployments. You can have one large model like GPT-5 for heavy reasoning tasks and a smaller one like GPT-5 mini for lower customization and classification. And also you may have a text embedding deployment. It can be a large or a small for generating the vectors that your AI search index will use. The next layer is AI search, and I think this is the one that most demos skips. A demo sends a request to OpenAI and it expects that the model knows things that it was not trained on. A production AI application retrieves relevant private enterprise data from data sources like SharePoint, SQL, Cosmos DB, it injects this one as a context and then sends that in the prompt and then call the model. That's RAG. Right now, AI Search supports two RAG architectures. The first is classical RAG and the other one is agentic retrieval. For the classical one, your orchestration code just sends a single query to AI Search. It gets back a ranked list of document chunks. Out of those chunks, it takes the top results and packages into the prompt and sends that to the model. It is simpler, it has fewer moving parts, but it's not the actual recommended anymore. Recommended one is agentic retrieval, which is more complex, and I won't explain here because it will take more time and it is out of the scope. In both cases, this search uses hybrid search, which means it is using a keyword and a vector search. And on top of that, we have semantic ranking. Internal enterprise APIs are required because your AI app just won't answer questions from index documents. In a real enterprise scenario, it needs to take action. For example, it needs to check for records or look at the CRM, create tickets, fetch real-time data from internal systems. So that is why it is required for this type of architectures. When you create a demo, you usually have keys floating around, but in a real production architecture, you shouldn't have that. You will use managed identities end to end. In this case, you could have a web application that has system assigned identity and will authenticate to Azure API management using that. Azure API management will validate that using Entra ID. Azure API management will get its system assigned identity and will authenticate to Azure OpenAI using the cognitive services user role. And Azure AI Search will get its system assigned identity to authenticate to Azure OpenAI to access the embedded model when it is running the vectorization pipeline. The last piece of this architecture is app insights using Azure Monitor, and it is crucial for a production architecture that you have observability in place at every layer, because doing so you will know what is the correlation between every layer. For example, what is happening between the frontend and the API management, between API management and all the backend services that you have. Additionally, when you have observability in place, you can query logs to identify which subscription is consuming most of the token this week or this month. And also you could identify what are the requests that are triggering the content filtering. Architecture is done. So let's take a look at the actual code that makes this happen. There's two things that we'll be looking at. The first thing is APIM policies that enforce governance on every AI request. And the other part is the Python code that does two things: the RAG orchestration for retrieval, context injection, and OpenAI call, and the client part. Before I show you the APIM policies and the Python code, I want to show you the Bicep code that deploys this, because I always like to have a full picture of the whole deployment. So the first part that you see here is the observability. So we deploy a log analytics along the app insights. Then we have the Microsoft Foundry. Just Microsoft Foundry, we are not deploying any hub, and we do then 3 deployments: the GPT-4o, which is the large, what I mentioned. We can use one large for complex tasks, and then the mini for lower cost tasks such as summarization or classification. We also have the text embedded in model, which will allow AI Search to do the vectorization at indexing time. Then we create the AI Search. Remember that to do semantic caching from APIM, we need Azure Managed Redis. So that's what we are deploying here. After that, we have the APIM management instance itself. We deploy the instance. We assign, of course, the system assigned identity. We also have observability here in APIM using this APIM logger. And the official documentation talks about be careful with 100% sampling of your insights. So for this case, this is using 20% of sampling to avoid any APIM throughput. This is the part that is setting up APIM with Azure Redis cache, and in this side we will be setting up the APIM backends, the APIM backend for the OpenAI deployment, which is the GPT. Then we have the text embedded in, and finally the AI search. Some name values that we define to choose the OpenAI version and the deployment name, so that we can switch without changing anything from the policies. We create the API definitions. We are doing a pass-through, so we allowed all the operations. This is how we do it. So we define the API and we define the get and post operations to this API. And finally here, the APIM policy, but I will discuss this one in a moment in another file. From the hosting side, we are creating an app service plan and the app service attached to this plan. This is a Linux plan, and this will be a Python app service in that plan. We have defined some app settings into that application so that the code can read it automatically, and we will see in a moment how that is working. And finally, we have the role assignments that we talked about in the beginning. Remember that we need APIM to be able to talk with Foundry, to AI Search. Then we need also the app service talking to Foundry, and we also even need AI Search talking to Foundry because it needs to reach the embedded in model. This is the policy that we have in APIM. Remember, APIM have inbound, outbound policies. In the inbound side, we have the authentication. So what this does is this lets APIM to issue a token so that it sends that token to the backend services. The APIM identity needs to have the cognitive services user if it is connecting to OpenAI, and the AI search reader if it is connecting to AI search. Here are the policies for AI request. The first one is the LLM token limit, because remember that OpenAI by default doesn't have that. So we want to ensure that if we have multiple applications using different subscriptions connecting to the same endpoint, we want to restrict the tokens per subscription. So that's basically what we do here. We are assigning a 10K per subscription, and this one is very important because this will allow to APIM to estimate the remaining tokens before it sends the request to OpenAI, so that one request don't exceed the tokens limit. And also the remaining tokens are stored in this variable to use later. The next one is the semantic caching, and in this case we are using a threshold of 0.85. This will specify with which OpenAI model we'll be using, which is the embeddings, and this is specifying to use the system assigned identity as an authentication to OpenAI embeddings backend. The last part is setting the backend service to be the OpenAPI GPT backend, and in the output we are storing the vectors for new prompts, the ones that are not similar to what we have stored, so we just cache them for 1 hour. There is one last part that I want to discuss with you, and it's the Python code. So we have two files, which is the application. This is the frontend, which exposes a chat. This will accept a question and a conversation and history optional, and then the response from the LLM will be something like this, which will be answered based on some documents that we have as a context, so it will also return the sources. The logic is calling the answer question, which is in the other file, and I will show you that in a moment, and it will return that response in this format. The RAG file is a bit more complex and contains a few things, so let me go one by one. The first thing that you notice is the clients. So we have two clients, one for the search and another for OpenAI. And for the OpenAI, we are using the APIM endpoint, not the OpenAI directly. So this will allow us the AI governance that we were talking before. For the search client, we are using the credentials that we get from Enter ID using the system assigned identity for the app service where this is going to be deployed. The context is basically a hybrid search doing a keyword and a vector search. So this vectorizable text query takes the raw text, which is this question, and lets AI search to handle the embeddings. So you don't have to make any extra API call to do the embeddings for this raw text. It will be handled automatically by Azure AI Search. And then we just get those sources and we just store them in this list, and we return the sources and the context. Then we have the answer question, which is the method that called retrieve context. It get the context, the sources, and now we are building the system prompt. The system prompt is the one that we will pass to the LLM, and this will need to pass the context. And finally, we call OpenAI client with chat completions, and we are passing the messages. Remember, the messages are the system prompt that we added it, and the conversation history if there is any. And then finally, we just return the answer and the sources. And that's all I wanted to show you for today. You know already that this is not a demo application because it is not talking only to OpenAI endpoint. This is a production architecture that has 7 layers. However, this code is just a starting point, not a finished product. Your product version will have private endpoints, will have Azure policy, and will have more complexity, but you get the general idea. APIM for governance, AI search for retrieval, OpenAI for generation, and managed identity for authentication. And don't forget observability and app insights for all your layers. So subscribe for more content like this, and I hope you like. Bye bye.